In the heart of the Midwest, a cathedral of carbohydrates wakes up.
This facility produces 4 million pounds of dough every single week.
It begins with the arrival of high-protein spring wheat flour. Precision logistics ensure the massive silos are never empty, keeping the line moving 24/7.
But before a single grain enters the building, rigorous quality control protocols must be met.
Security seals are verified to ensure the raw flour hasn't been tampered with during transit.
Once the seal is verified and cut, the transfer process is cleared to begin.
A dedicated food-grade hose connects the truck directly to the factory's circulatory system. A hermetically sealed connection prevents any outside contaminants from entering the stream. Powerful pneumatic pumps generate the pressure needed to move solids like fluids. The flour travels at high velocity through the intake pipes, looking like a blizzard in a tunnel. These massive silos hold 50,000 pounds of raw ingredients each, standing guard over the factory.
Internal pressure is carefully monitored to prevent clogging or structural stress.
Unloading a full tanker takes approximately 45 minutes of continuous pumping. Meanwhile, inside the facility, minor ingredients are staged for the daily mix.
Sugar, salt, and yeast are stored in specific climate-controlled zones to maintain freshness.
This is the mixing deck, where simple chemistry is transformed into culinary art on a massive scale. The recipe is automated. The computer doses flour to within 1/10 of a pound. 1,000 pounds of flour enters the bowl in a matter of seconds. Chilled water is crucial. It controls the dough's temperature during the violent mixing process. Soybean oil is added next. This gives the final crust its tenderness and texture.
Fresh yeast is added manually. It is the living enzyme that will make the dough rise.
Safety guards lock into place. These machines have enough torque to crush a car. The massive agitator bars begin the incorporation phase, moving slowly at first.
At first, it's just a shaggy mass of wet ingredients, lacking structure.
Then, high-speed mixing begins. This develops the gluten structure rapidly. This stretching aligns the proteins, creating the signature elasticity of pizza dough.
Every second of mixing is accounted for. Too long, and the dough becomes tough.
Friction generates immense heat, which is why we started with ice-cold water. Once the cycle is complete, the massive bowl tilts for discharge. A single batch weighs nearly a ton. It creates a satisfying thud as it drops. It is caught in a sanitized transfer trough, ready for the next stage. Gravity will do the work for the next stage. The trough is hooked to a hoist. The dough is hoisted high above the dividing machinery. It drops into the hopper of the volumetric divider system. Internal augers gently compress the dough to remove large air pockets.
Pistons measure the dough by volume, not just weight.
Each piece is cut to an exact specification. This is the birth of a pizza. The rough chunks begin their journey down the long production line. An automated inline scale verifies the weight instantly. Accuracy is everything. Anything outside the strict tolerance is automatically rejected and recycled. Centrifugal force shapes the rugged chunk into a perfect sphere. Now perfectly round, they are ready for the most critical step, proofing.
The rounding process creates a tight outer skin that seals in the fermentation gas.
The line splits into 6 lanes to maximize the tunnel's capacity. A light dusting of flour prevents sticking on the belts during transport. The proofing tower is a controlled biosphere for our yeast. Inside, the dough travels on a massive spiral for 40 minutes.
High humidity keeps the skin from drying out while the dough rises. The yeast activates, creating bubbles of carbon dioxide that expand the dough.
Thousands of future pizzas are rising simultaneously in this steel tower. Operators monitor the rise without disturbing the temperature.
By the time they reach the top, the gluten has relaxed.
Gravity brings them back down to the production floor via a spiral chute. A brief rest period settles the internal structure after the slide.
The finger poke test confirms the dough is alive and ready for packing.
Precision alignment is needed for the high-speed robots ahead.
They are now ready for packaging, but they need clean trays first.
Hygiene is paramount. Every tray is recycled and scrubbed for every use.
The dough trays enter a high-pressure washing tunnel the length of a bus. Scalding water removes every trace of old oil or dough residue.
Mechanical brushes target the hard-to-reach corners to ensure total cleanliness.
A final sanitizing rinse ensures sterility before they leave the machine.
Air knives strip the water off instantly. Any moisture left on the tray could ruin the next batch of dough. Precision sprayers apply the release agent automatically.
A micro layer of oil prevents the dough from sticking to the plastic later.
It is just enough oil to release, but not enough to be greasy.
Ultraviolet light provides a final kill step for any airborne bacteria.
The clean trays and fresh dough finally meet at the robotic cell. The Delta robots are the fastest hands in the factory.
They operate at speeds the human eye can barely track.
Soft vacuum grippers are gentle enough not to bruise the proof dough. 6 dough balls are grabbed simultaneously in a fraction of a second. They land in a perfect configuration, ready for storage. Uniform spacing allows for even cooling in the next stage. A heavy lifter robot takes over for the stacking process.
The trays form a complete stack, holding 120 dough balls.
The full stack weighs over 300 pounds.
The factory floor becomes a highway of moving white towers. The dough is currently warm and rising. It must be stopped immediately. To pause the yeast activity, we must freeze time.
The blast freezer is a tunnel of Arctic wind.
Temperatures here drop to 20 degrees below zero. The plastic trays flash freeze instantly in this environment.
Rapid cooling pulls the heat from the core of the dough.
This doesn't freeze it solid, but chills it to a dormant state.
The journey through the tunnel takes 90 minutes to complete.
They emerge perfectly chilled to exactly 38 degrees. A layer of frost coats the exterior, but the dough inside is safe.
Technicians verify the core temperature is safe before shipping.
Perfect. Cold enough to sleep, warm enough to survive the trip.
Now we build the shipping units for the trucks.
The palletizing robot is the strongest arm in the building. It lifts 300 pounds effortlessly, day and night. It places the stack on a standard pallet base.
Four stacks make a full pallet.
Over 1,000 pounds of dough moves to the wrapping station. High-tension film locks the stacks together into one solid brick.
It creates a single, solid shipping unit that won't shift in transit.
Stability is key for transport, so we wrap it tight. Every pallet gets a birth certificate with date and time. Fresh dough has a shelf life. The clock is now ticking. Forklift drivers act as the factory's circulatory system. They secure the load and lift it away. We enter the cold storage cathedral.
This warehouse holds enough dough for 1 million pizzas.
The entire room is kept at a constant, chilly temperature.
Inventory is rotated strictly. First in, first out.
It won't stay here long. Inventory turnover is extremely rapid.
Every pound is tracked digitally in the central system. Outside, on the loading dock, the fleet is waiting.
Rain or shine, the trucks roll out every night.
The trailers are essentially rolling refrigerators.
Maintaining the cold chain is the final, crucial challenge.
Loaded, locked, and sealed.
The driver starts the journey to your local store. From a wheat field to your front door in under a week.
is the massive scale of better ingredients.